Dear students, today we are going to discuss on the topic semiconductor theory. In semiconductor theory, we are going to discuss what is energy level and energy band, energy level of single isolated atom, classifications of energy band, last energy band diagram of conductor, semiconductor and insulator. Now what is energy level? Energy level is basically electron orbits from the nucleus. Electron can revolve only in these permitted orbits, not any intermediate orbits. Now each orbit has a fixed amount of energy. The different orbits have different energies. The orbit which is closest to the nucleus has the lowest energy, and the orbit that is the outermost orbit has the highest energy. From here we see that the energy of different orbits are different. Suppose energy of first orbit is 0 electron volt. We represent energy level in electron volt. Suppose energy of first orbit is 0 electron volt. Energy of second orbit is 3 electron volt. Energy of third orbit is 6 electron volt. And energy of the fourth orbit is 9 electron volt. Now energies of different orbits are represented by the horizontal line. These are called energy level diagram. Here the energy of first orbit is 0 electron volt. Energy of second orbit is 3 electron volt. Energy of third orbit is 6 electron volt. And energy of fourth orbit is 9 electron volt. Energy level is a quantized energy value of an atom because it can take certain amount of energy value. This is energy levels of single isolated atom. First is absorption of the atom. In absorption of the atom, electrons are in the ground state. Initially electrons is in the ground state. Ground state means the lowest energy state, that is called ground state. Now when electrons absorbs a photon, electron gains energy and becomes excited. Then electrons jumps from lower energy state to higher energy state. Here electron absorbs photon and becomes excited. Electron jumps from lower energy state to higher energy state. This is called excited state. So these are the excited state. Excited state means energy state which is greater than the ground state. So these are the excited state, and this is ground state. Next is emission of the photon by the atom. Here initially electron remains in the excited state. Now when electron emits a photon, electron loses its energy and jump from higher energy state to lower energy state. Here electron emits photon and jump from higher energy state to lower energy state. This is called ground state and this is called excited state. Next, what is energy band? Energy band is basically range of energies of electrons in the same orbit. So these are the energy band. Now there are two types of energy band. One is valence band and other is conduction band. Valence band is basically the highest occupied bands. These are the occupied bands and valence band is highest occupied band. Now electrons in the valence band are called valence electrons. In valence band, all the permissible energy levels are occupied by valence electrons. In valence band, no electron can move, so valence electrons can't contribute any current. Next is conduction band. Conduction band is the lowest unoccupied band. These are the unoccupied band, and conduction band is the lowest unoccupied band. Under normal condition, conduction band is empty. This is the clear picture of valence band and conduction band at absolute zero temperature and at room temperature. At absolute zero temperature or 0 Kelvin, valence band is completely filled with valence electrons, but conduction band is empty. At room temperature, valence electrons gains energy and becomes excited. Then they breaks covalent bond and jump from valence band to conduction bands and become free. So in conduction bands there are free electrons. Free electrons means the electrons which are free to move in the solid are called free electrons. These free electrons are responsible for current conduction. That's why these electrons are called conduction electrons. Free electrons are the responsible for flow of current. Next, the gap between valence band and conduction band is called forbidden gap. Sometimes forbidden gap is called forbidden energy gap or band gap or forbidden band. Forbidden gap determines the conductivity of electrons. Less forbidden gap means greater conductivity. Electron can't exist in the forbidden gap because there are no permissible energy levels. Okay. Now this is the energy band diagram of conductor, semiconductor and insulator. In case of conductor, valence band and conduction bands are overlapped here because here forbidden gap is equals to 0. Therefore, electrons in the valence band can easily enter into the conduction band. But in case of semiconductor, forbidden gap is very small. Therefore, at absolute zero temperature, semiconductor behaves as an insulator. But when we apply a small amount of energy, then electrons in the valence band gains energy and becomes excited. Then they breaks the covalent bond and jumps from valence band to and conduction band and becomes free. As a result, semiconductor starts to conduct. But in case of insulator, forbidden gap is very large. Therefore, large amount of energy is needed for an electron to jump from the valence band to conduction band. So in case of insulator, large amount of energy is required. Thank you. If you like my video, so please like and comment. Thank you.